everyone, I'm Steven, a product manager for OSS at Alibaba Cloud. And we are living in an era where its definition of storage is being fundamentally rewritten. For decades, object storage service was where you put data to keep it safe. But today, in the AI native era, keeping data safe is not enough. We need to understand data. So today, I'm so glad to introduce how we are reinventing data intelligence through two breakthrough capabilities. And one is OSS Vector Bucket, and another one is Metaquery. So let's start with why. Every organization today is sitting on a mountain of data. But as volume grows, the percentage of useful data seems to shrink, which actually drives AI applications and creates value. And data is often called the new oil, but raw oil cannot power a jet engine. It needs to be refined. In the world of AI, the challenge isn't just storing petabytes of images, videos, and logs. It's about discovering the valuable signal within the noise. So how do we find that value? We are seeing a massive shift toward vectorization and AI inference. By extracting content features and turning them into high-dimensional vectors, we transform unstructured raw data into a format that large language models can understand. In this ecosystem, OSS acts as a fuel tank, while the VectorDB and large language models act as an engine. The goal is to create a seamless pipeline where raw data becomes actionable intelligence. However, traditional methods are hitting a wall. If you've tried to build an AI data pipeline recently, you know the pains. And the first one is about complexity. You have to manage separate storage, separate embedding services, and separate vector databases. And second one is about limited scalability. The form of database determines that enterprise must consider its scalability, requiring multi-instance, multi-table, and instance migration, table migration architectures. And third one is about cost. An entire set of infrastructure is expensive, and it cannot be guaranteed that enterprise can profit from it. To solve this, OSS is evolving. We are moving beyond a general-purpose bucket into an AI-native data platform. As you can see on this slide, we are introduced two major pillars. And the first one is Metaquery with AI content-aware for unstructured data. And the second one is Vector Bucket for massive-scale vector data management. Okay, let's look at the first pillar, OSS Metaquery. Traditionally, if you wanted to find a video in OSS, you searched by object key or object tag. But what if you need to find a video of an airplane flying through clouds and landing smoothly? Metaquery now integrates embedding and large language models directly with your storage. It automatically extracts multimodal metadata, not just file size, but semantic descriptions, visual captions, and even specific bit rates, allowing you to query your data using natural language. So how does it work? It's completely serverless. When you put object into OSS, we handle the video frame capture, text feature extraction, and vision embedding using models like Q1VL. The results are threefold. The first one is zero infrastructure. You don't have to build your own labeling or vectorization clusters. And the second one is high accuracy. Our multi-pass recall and ranking algorithm ensure that you can find what you need. And the third one is about cost. Because by deploying a content-adaptive video frame algorithm, the total cost can be reduced by 80%. So for deeper understanding of your content, besides semantic query, we also offer character naming. Instead of system telling you a man is in the yard, you can train it to recognize dad or grandpa. By naming specific individuals in your character library, OSS becomes an intelligent content manager. I'd like to say this is a game changer for smart home applications or private media asset management. At this time, OSS Metaquery will identify other faces outside the character library as strangers and recognize the risk of strangers. For example, a stranger appeared at a door or a stranger is playing with baby at a door. This must be a critical security feature. And beyond this searching, Metaquery can monitor. You can register custom event roles. For example, notify me via MNS, which is message service, if an express delivery arrives or if someone falls down. OSS intelligently evaluates the content of uploaded objects in real time against your rules. This can turn your storage bucket into a proactive, event-driven engine. Okay, now let's talk about the second pillar, vector storage. As vector data explodes, we are seeing a shift in storage architecture. We started with in-memory architecture, which is fast but expensive, and then moved to on-disk architecture, which is a balanced architecture. And now we are moving to object storage-based vector storage. So why? Because for long trail of the massive AI data, you need infinity, scalability, and low cost of OSS. And here is an introduction of OSS Vector Bucket. Vector Bucket is a brand new bucket type designed for vector data. It's not just a flat object store, it supports vector indexes. You can create up to 100 indexes per bucket. Then, in the vector index, you can put your vector data along with its filtering metadata for post-filtering and non-filtering metadata like descriptions. Whether you use ECS or Alibaba Cloud Model Studio for embedding, you can now store and query those vectors directly within OSS using a simple RESTful API. So, what makes it special? And first one is about cost saving. Compared to traditional vector databases, our total cost is dramatically lower. You only pay for storage and the data scanned during queries. And the second one is our extreme scale. A single account can hold hundreds of billions of vectors. And third one is about serverless and easy to use. There is no cluster to manage, and you can go from 0 to a searchable index in minutes. By integrating the vector bucket into your ecosystem, we achieve a unified vector lake. And you have your raw data and your vector data in same place, OSS, and you can store all of your vector data in OSS Vector Bucket to fulfill your retrieval need in the scenario of hundreds of milliseconds query latency. And also, if you have high-performance query requirement, you can export your vector data to vector database like table store in order to query your data in 30 to 40 milliseconds. So in this vector lake, you have your raw data and your vector data in same place, and you can manage the entire lifecycle of that data, from the raw bits to the searchable vectors. This integration simplifies your CI/CD pipelines, ensures consistent data security through unified RAM policies, bucket policies, and so on. So let's look at some real-world use cases. And the first one is about a cost-effective enterprise RAG. So the RAG is retrieval augmented generation, and it's very popular today. And most companies have massive knowledge bases. Using a traditional in-memory vector DB for all data is too expensive. And by moving to the code or warm data to OSS Vector Bucket, enterprise can maintain a massive knowledge base with a 95% reduction in total cost. And the second user case is about e-commerce. In the before scenario, different departments like A, B, and C often maintain their own isolated vector databases, leading to redundant embedding and wasted resources. With OSS as a unified vector storage platform, everyone shares a single source of truth. You embed it once, store it once, and create different indexes for different scenarios, like similar product search or related recommendations. And third use case is about advertising platform. And we worked with a customer who provides global marketing services. They use a hierarchical architecture. They use Elasticsearch for high-frequency hot data queries. But they use OSS Vector Bucket at their vector data lake. This allows them to store massive amounts of historical advertising data at a fraction of the cost, only warming up data into ES when needed. So, and how to use Vector Bucket? In fact, we have offered lots of approaches. You can manage everything via the OSS console or use our RESTful APIs. And we have a full SDK support for Java, Python, and Go, and our command line tool, OSS util, is fully updated to handle vector operations like put vectors and query vectors. So where can you use it? And now it is an invitation preview, and it's available right now in Singapore, Beijing, Shenzhen, Shanghai, and other regions. And starting from February 1st, 2026, we will launch a public preview and extend to Indonesia, Germany, and US, both East and West, and Hong Kong. We want you to try it today and see how it transforms your AI workflow. Okay, so last, let's warm up. The AI native era requires a new kind of storage. With OSS Metaquery and Vector Bucket, Alibaba Cloud is giving you the tools to turn your data from a cost center into a value engine. And thank you for your watching, and I'm looking forward to seeing what you build with these capabilities. Thank you.
Hello everyone. Thank you for joining this session. My name is Sean Phua, and I'm a storage product solution architect here at Alibaba Cloud. Today, I'll show you how to build a multimodal AI search engine where you can perform search using natural language, photos, or even videos, all powered by the new OSS Vector Bucket and the Alibaba Cloud Model Studio. So here's what we'll cover today. I will go through the trends and evolution of vector data storage, and then I'll introduce the new Alibaba Cloud OSS Vector Bucket, the end-to-end demo architecture, followed by the live demo, and I'll quickly recap the demo and run through on other real-world use cases and why Vector Bucket changes everything. Lastly, I will go through how we can get started today. So before we dive into how vector buckets work, let's step back and look at what is driving this shift from how we store and retrieve vectors. So firstly, we have seen an explosion in vector data generation. So modern AI applications don't just process text. They analyze large volumes of unstructured data, such as images, videos, audio, and documents. And each of those get converted into high-dimensional embeddings. We are talking about billions of vectors growing every day that has to be stored and managed. Secondly, cost has become the primary constraint. So it used to be that building models was the hard part. Now, infrastructure costs often exceed development costs, especially when you're running dedicated vector databases at scale. So enterprises and teams are always looking for ways to reduce their TCO without sacrificing capability. And thirdly, we have seen latency tolerance is growing for end users. So not every AI application needs sub-millisecond responses. In fact, many RAG and recommendation systems can deliver great user experiences with sub-second retrieval times, as long as the results are relevant and reliable. So this creates a powerful opportunity. We can trade ultra-low latency for dramatically lower costs, all without hurting the end user experience. So these trends has forced a fundamental rethink of vector storage, and we have seen a clear evolution. Early vector databases stored everything in RAM for speed, but when you're at billions or potentially trillions of vectors, this will become financially unsustainable. The next generation moved to disk-backed architectures with caching layers. So this is better on cost, but they introduce operational complexity, tuning overhead, and scaling bottlenecks. So now, we're entering a new paradigm, which is object storage-based vector storage. So by building vector search directly on top of highly durable, infinitely scalable object storage, we can get the best of both worlds: virtually unlimited storage capacity and dramatically lower cost with simplified operations. And this serves as the right foundation for the next era of AI applications that prioritizes scale, cost, and developer velocity over raw, unrestrained performance. And this is where exactly Alibaba Cloud OSS Vector Buckets come in. It is a new bucket type inside Object Storage Service that is purpose-built for this new reality. We can break down Vector Bucket into 3 basic layers. In layer 1, which is the bucket itself, we can store vectors as float32 arrays alongside rich metadata text that you can choose to use for scalar filtering. In layer 2, we have the indexing engine, which allows you to store up to 100 indexes per bucket. And it supports vector similarity search using multiple distance metrics such as cosine similarity or Euclidean distance combined with metadata filtering. In layer 3, we have the flexible integration. You can write vector data from a variety of sources such as our ECS Elastic Compute Service, our Pi platform for AI, our Model Studio, or any other external embedding models. And then you can read your vector data via the OSS SDK, API, or the OSS YouTube. So vector buckets merge the economics of cloud object storage with native vector search intelligence, and it delivers a scalable, cost-efficient retrieval that is optimized for the performance sweet spot that most AI applications actually need. It is serverless, language agnostic, and can be managed just like your existing OSS bucket using standard OSS API, SDK, OSS YouTube, the OSS console. So there is no need for any tuning, no need for any scaling. You just need to upload and you can search. So I'll go through the demo pipeline for today. So for the raw data, I have about 1,000 photos and videos of landscapes, animals, cityscape that is stored inside a standard OSS bucket. So in real life, your source data can also be sitting in an external storage environment. For the embeddings, I will use the Model Studio's Qwen Multimodal embedding model to convert the images and videos into unified vectors. Next, for the ingestion, I will call the Put Vectors API to store my embeddings along with any other metadata, such as the category, the source of the image or video, into my OSS Vector Bucket. And then during user query, users can search using natural language such as futuristic spacecraft in the depths of space, or they can search using images or even videos. So we will embed that text, image, or video query using the same Qwen multimodal model, and then we'll call on the Query Vectors API to perform a cosine similarity search to return the top matching results. Okay, so now let's see the demo in action. Okay, so I'll start here with a standard OSS bucket containing my raw images and videos. So I also have an inventory list CSV file here that will list every file name to be embedded inside this bucket. So to illustrate the embedding process, I have built a simple interface. So firstly, I will upload a local image in my computer. So this image is a black and white photo of a school band. And then I will select the embedding model to use over here. I will go with the Tongyi Embedding Vision Plus model. And I'll click on Process Image. So what it will do is that I will send the image to Model Studio's API, which will then use this Embedding Vision Plus model to embed this image. And then it will generate a 1152 dimension vectors over here. So this vector encodes the semantic content of the image so that later when we search, we will be matching for the meaning and not just the file names or the pixels. So to fully embed my source data set of images and videos, I have this Python script that will firstly download the CSV file, from my OSS bucket, iterate through each file name and fetch the corresponding image or video URL, and then send it over to Model Studio for embedding using the same Qwen multimodal model. So just a note here that you can use any embedding model, no matter if it's Alibaba's Cloud's Qwen models, other open source models, or other proprietary models. As long as the model produces consistent and fixed dimension vectors, you will be able to store and search these vectors inside the OSS Vector Bucket. So I will save all of these resulting vectors and metadata into a local file called embedding.json later. And it will take some time to finish this embedding process as we have almost 1,000 pictures and videos. So in the meantime, I'll set up the new OSS Vector Bucket for us to store the embeddings. So this process would be very similar to how you create a standard OSS bucket. You can do it through the OSS console, through the OSS util, SDK, or API. So over here, I will give it a name. I'll go with Vector Bucket Demo, followed by today's state. For the region, I'll specify the Singapore region and then create the bucket. So I'll go into the vector bucket, and the next step is for us to configure the vector index. So for the vector index, I will have to configure the vector name. I'll have to configure the vector index name. So I'll go with vector index 1. And then for the vector data type, I'll leave it as the default float 32. And for the vector dimension, I will have to input 1152. So this is because every embedding that we generated with our Quen embedding model has exactly 1152 dimensions. So all vectors that will be added under this index must match this dimension. Next, I'll choose the distance metric function for retrieval later. Over here, I will choose the cosine similarity because for high dimensional embeddings like ours, cosine similarity will be more robust for capturing semantic meanings, which makes it a standard choice for multimodal search across unstructured data such as text, images, videos, and even audio. And then lastly, I can also optionally configure up to 10 non-filtering metadata fields for descriptive context. So this could be metadata text like captions or source URLs. Okay, now I have created my index. And let's check on the process of our embedding. So we have successfully embedded all of the images in my OSS bucket. And then the output is stored in this embeddings.json file. So we can see this JSON file contains all of the vector data of my source data set. And then what I'll do next is that I'll upload the contents of this embeddings.json file into my newly created vector bucket using this Python script that will call the OSS put vectors API. So each entry will include the vector itself as a float32 array of 1152 dimensions, a unique key. In this case, I use the original OSS object key, and any metadata that we'll be using for filtering. So could be like the category of the image, category of the video. So we can see that the ingestion has been completed. I'll go back to my console, do a refresh. I can see all of my data has been loaded inside. I have the vector key, the vector data, and any metadata that we use. So the next step, once the ingestion has been complete, we can go to our semantic search. So I've created a simple interface here. So I can start off with a text-based search, futuristic spacecraft in the depths of space. So what I will do is that I will send this query text to the same Quen multimodal model to generate a query vector. This query vector with a dimension of 1152. And then I will call the query vectors API on the vector bucket and send the query vector, the top K, which is the number of relevant results to be returned. And then I can see the results that will be returned to me from the vector bucket. These are the top matching results to my text query. So I can also see for each of the result, I can see the distance, I can see the metadata over here. And these matches are based purely on vector similarity. There is no keywords matching, there is no manual tagging. And also, thanks to Vector Bucket's optimized indexing, this retrieval runs in sub-second time. In fact, a single query vectors API requests can return up to 30 results with a recall rate of approximately 90%. Okay, so now what if I want to search using an image instead of text? So over here, I can upload a local image. So this is an image of a dog. And then I will just change the top K parameter here. I'll change it to 6. And if I also want, I can choose to specify the category or the height and width of the image. So I will not do it for this search. And then similarly, I will embed this image of my dog using the Qwen multimodal model to get back a 1152 dimension query vector. And then I'll call the query vectors API on the vector bucket. And here are the results. So I have images of my dogs that are the most similar to my source, to my local image over here. Just like before, this returns the results in sub-second latency with approximately 90% recall for our top matches. Okay, so now let's take a step back and see what we have just accomplished. So we started off with the raw images and videos in a standard OSS bucket. And then we embedded them using any model of our choice. So in this case, I used the Alibaba Cloud's Qwen multimodal model. I created a vector bucket and I ingested the vector data using the standard OSS API. And then lastly, I perform text-to-image search to get my relevant result, and also an image-to-image search. I uploaded a photo of a dog to get back results of similar dogs. So both of my queries ran in sub-second time and returned high-quality matches with approximately 90% recall. And while today's demo focused on semantic search, OSS Vector Bucket unlocks value across many real-world scenarios. So I will highlight 3 over here. Firstly, for cost-optimized RAG, many enterprises use expensive vector databases for their RAG-based knowledge bases. However, not all queries need ultra-low latency. So for eternal Q&A, where around 90% recall rate is sufficient, Vector Bucket can deliver dramatic cost savings without sacrificing on usability. Secondly, in multi-agent systems, you often have high-volume, low-stakes queries alongside your latency-sensitive and precision-critical ones. So, Vector Bucket can act as your cost-efficient first tier for your bulk retrieval. And when you need precision-critical and latency-sensitive queries, you can escalate them to Table Store, which is Alibaba Cloud's high-performance NoSQL database. So you're able to achieve the best of both worlds in terms of cost and performance. And then thirdly, for unified AI content management, many teams store their raw media inside object storage and their embeddings in a separate vector database. So this means that they have to manage 2 systems and sync metadata across different platforms. So with Vector Bucket, both of your raw data and vector can live under OSS, and then you can access them from the same console, same OSS SDK API, with the same OSS management model. There is no fragmented architecture here, just one platform for all of your AI data. So in short, whether you're building a RAG system, an AI agent, or your media search, Vector Bucket can help you to do more with less. And before Vector Bucket, moving from raw data to AI applications can take months, from provisioning clusters, building pipelines, managing costs, and your developer teams learning entirely new frameworks. So now, you can go from simple storage to extracting value from your data in days or even less. So this is a fundamental shift in how enterprises can ship AI. So I hope you are ready to build. So you can scan any of these QR codes here on the screen to follow our demo guide and build your own semantic search system on OSS Vector Bucket. Or you can create your own Vector Bucket inside OSS. And lastly, I also encourage you to check out Model Studio, where you can explore Quent's multimodal models and our other flagship models available today. Thank you very much.